Hey guys, this is lesson 8.6 for course 2. This is about square roots. So title your paper Square Roots 8.6. Now, square roots, if you know the area of a square, you can find the length of its side by taking the square root. So here is an example. This square has an area of 25. So there's my area. And if you remember, we've been doing area of trapezoids, parallelograms, triangles, all those shapes, circles. So now we're looking at how do we find the numbers that equal the base and the height. So anytime you have a square, all your sides are the exact same. So what they do is they say, okay, if the area of your square is 25, if you want to find just one of the sides, you take the square root of 25. Now, the square root means what number times itself equals 25. So when you take the square root of 25, you would get 5 times 5, because 5 times 5 is 25. So the square root of 25 is 5. And further on, if you keep going, the square root of 9 would be 3, because 3 times 3 is 9. And the square root of 16 is 4, because 4 times 4 is 16. And the square root of 100 is 10, because 10 times 10 is 100. So, this is called a rational number. So you have two types of numbers. So make sure you write both of these down. First, we have a rational number. A rational number is a number that ends or has a pattern. So, for example, the square root of 36 equals 6. Both of those are rational numbers. Or 2.6 repeating, which would look like this, 2.66666. Because that has a pattern, that is a rational number. Or if I did 1.375, that is a rational number because it ends on my calculator. If I look on my calculator and it ends or it has a pattern, then it is a rational number. An irrational number, I always think, if you think of the word irrational, I think crazy. So irrational is a number that never ends or has no pattern. So all of our perfect squares are rational. However, if I took the square root of 27, I don't know what times what would be 27. Well, when I put it in my calculator, I get this long, crazy number. So that is an irrational number. Like the number pi that we just talked about, 3.1415, and then it goes on and on and on in a crazy pattern. Doesn't have a pattern. That is an irrational number. All right, so what you're going to be asked to do is estimate square roots. So if I asked you to estimate the square root of 30, you would see that, all right, so the square root of 25, the square root of 25 is 5, and the square root of 36 is 6. So the square root of 30 would be in between here. Now, it would be 5 units, so I have to figure out what it would be. It would be 5 units away from here. From 25 to 30 is 5, and from 30 to 36 is 6. So I would say it's about right in the middle. So you could estimate this as 5.4 or 5.5 as your answer. So let's try another one. Estimate the square root of 50 and estimate the square root of 13. Push pause. Try these, and then we'll go over them. All right, so here's my strategy. I have the square root of 50. Now, you want to think of the perfect square roots on the top and the bottom. So if I know that the square root of 49, because that is 7 times 7, that's 7. And then I know the square root of 64 is 8. I'm looking at the number underneath the square root sign. So then I go 49, 50, 64. So then if you look at it, oh my gosh, it's a lot closer to 49. It's only one number away. So my estimate would be 7.1. You round to the tenths place when you're estimating square roots. And it's going to be a little bit more because it's not a perfect square, so you can't say it's 7. So then you go up to a tenth. You go to 7.1. You go 1/10 of the way up. All right, the square root of 13. If I look what goes on the top and the bottom, I know the square root of 9 is 3. And I know the square root of 16 is 4. You're looking for your perfect squares. So this is a perfect square and this is a perfect square. Now, look at them. Okay, so to get from 9 to 13, that is 4 numbers. 9, 10, 11, 12, 13. Okay, 13 to 16 is 3 numbers. So it's a little bit closer to 16. So my estimate would be 3.6. I'm going more than half. It wouldn't be 3.5 because it's not evenly split right down the middle. And it's a little bit closer to 4. So that's why I went 3.6. Because if you think about it, then you have 3.7, 3.8, 3.9, and then you get to 4. So as long as you're close, as long as you have 3.5, 3.6, you would be correct. It doesn't have to be right on because it's just an estimate, remember. All right, that is it for your notes.